In this video, we are going to discuss about different types of cross-validation, and we'll also understand why cross-validation is actually used. Now, as you know that guys, you obviously have some data set. Let's consider that you have some data set over here. And this specific data set initially, whenever we train a machine learning model, first of all, we divide this data set into two parts. Okay. The first part is something called as training data set, right? And the second part, which we normally use or which we normally call, is something called as test data set. Now, 2 points I'm going to note it down over here. With the help of training data set, we will be training our model, right? So for training our model, we will basically be using this training data set. Along with this, the second point that I really want to mention is that for hyperparameter tuning also, we specifically use our training data set. Right now, when I say how do I do a hyperparameter tuning, there are various ways like grid search CV, randomized search CV, and all. And you may be considering, Krish, how training our model with the help of training data set and even hyperparameter tuning. Over here, what we do is that we further divide this data into two more parts. And this is basically called as train and validation. Right? So we split this data set more into train and validation. Okay. And with the help of this validation data set, we basically, try to hyperparameter tune the model. So here I'm going to write it as validation data set. Okay. So till here, I hope everybody's clear. But once we divide from this training data set into train and validation, in short, we are splitting this data set. So while splitting this, here specifically this training data set, my model will get trained and it will be validated with the help of this validation data set. And when we are validating it, in short, we are also hyperparameter tuning it. That basically means we'll play with multiple parameters. Now let's say initially I just have 1000 records. Okay. And let's consider that I'm using this 70% split and 30% split as my train and test split. This data that is present will only be used by my model to check the performance. So to check the performance of my model based on new data. Okay, based on new data, I will be using this test data. This test data will never be shown to the model at any point of time. Only after the model is trained completely, validated completely, then only this new test data will be shown, and then we'll check the performance by seeing a lot of performance metrics. Let's say accuracy, precision, recall, R square in case of R2 score. In the case of regression problem statement, mean absolute error, mean squared error, many different performance metrics which we have already discussed. Now let's go ahead and focus on this part where we split our data set from this training into train and validation. And for doing this split, we can apply something called as cross validation. And why do we do this? Because understand, if I try to do a split of training into this two part, that is train and validation, there is an important parameter which is called as random state. And as we change this random state value, you'll be seeing that we will always be getting a separate training data and separate validation data. So let's say on one of the split, I got 85% as my accuracy. In the other split, I may be getting 92% accuracy, or in other split, I may also get my accuracy getting reduced, like somewhere around 78 or 75. So this kind of scenario will always happen. And as a data scientist, we should be able to say that my model is probably giving an average accuracy of this much or of some specific value. And for that specific thing, we'll be using cross validation. Now, there are different types of cross validation which we usually use. Let's discuss about the first cross validation. The first cross validation that I would like to discuss about is something called as leave one out cross validation, which we specifically say CV. And the short form is, like, if I really want to use it, we will basically be writing it as LOOCV. Okay, leave one out cross validation. Now let's understand this. In this cross validation, what happens? Okay. You have to understand this word, leave one out, cross validation. So let's say currently in your training data. Now, when I say training data, I'm basically talking about this specific data, right? This part, because this split is obviously required. We are never going to use the test data from this data. So if I go down this training data, let's say the number of records are 500. Okay. Now further, I really need to split this data into training and validation data. So with the help of leave one out cross validation, what will happen is that we will be taking this 500 records, and out of all these 500 records for the experiment one, when I say experiment one, that basically means, let's say my cross validation, right now I'll not write cross validation. Let's say for my experiment one, the first record, one record, this will be put in my validation part. Okay. And remaining will be my training data, right? And my model will get trained on this training data and it will be validated by this validation data. So it is basically going to get some accuracy based on this particular validation data. Now, similarly, in experiment 2, what will happen is that the next record that you will be having will be taken as your only one record, right? Only one record. This record will be your validation. Okay. And remaining all will be your training data, right? This will also be your train. This will also be your train, right? And then again, you may get some different accuracy. Now, similarly, based on the data size, you will be seeing that we have to perform that many number of experiments, because at the end of the day, my validation data size is only one, right? Now, in this particular case, this will basically be my training and this will basically be my validation data. And again, this will be my accuracy 500, right? Now, obviously, what are the disadvantages with respect to this? This will be my experiment 500 because I have 500 records. Now, obviously, what is the disadvantage of this? If you're just taking one out cross validation at every experiment that we perform, we will be taking only one record as a validation data and remaining all will be a training data. And obviously, for performing this much, as the data set size increases, the complexity of training the model also increases, right? Complexity of training the model also increases, because if I have 5,000 records, let's say, then I have to probably perform 1,000 experiments. I have to make sure that each and every record is passed, and I'll be able to then calculate the average of all this accuracy. So obviously this is not a very good technique, and you know that this technique is no way used right now. In some of the cases we may use it. Okay. Now the second major disadvantage over here is that this model obviously leads to overfitting. Now, what does overfitting mean? Overfitting basically means, with respect to our training data, since we are taking the entire training data, my accuracy is very high, right? Here the accuracy is very high. Now, since my test data is very small, or I'll not say test data here, I'll say validation data, right? Since the validation data is very small, right, then obviously the accuracy will keep on decreasing, right? And when we test this same model with our new test data, then my model performance will go down, right? Model will not perform well. So the accuracy here will go down. So this is a major disadvantage. Usually we say overfitting, wherein your training accuracy is high and your validation accuracy is less. That basically means it is perfectly fitted the training data. And obviously, because the training data size is quite huge. Okay. Now, similarly, the second type, I can name it over here as leave P out cross validation. Okay. So here, instead of 1, you set some P value. Your P value can be 10, your P value can be 20, your P value can be 30, and this can be selected as a hyperparameter. Okay. The same process, everything is same. Okay. Now let's go ahead and understand the third important type of cross validation. And this cross validation is basically called as k-fold cross validation. So I will go ahead and basically write k-fold cross validation. Okay. Now let's say if your data set is size is 500, Okay, let's say the total data set that you are present in the training is 500. Now from this training, I need to split this into train and validation. And I will say, let my K value be 5. Okay, the total size of the data set, which is mentioned as N, is 500. Now what will happen is that we will try to first of all find out cross validation, how many different experiments we need to perform. Now in order to calculate, I will just divide 500 by 5, and here you will be able to see 100. Okay, so this should not be cross validation, but this should be your test size. Okay, and when you calculate the test size, how I'm calculating the test size? The total number of records divided by 5. Let me write it again so that this will be a super important point for you all. This, I am trying to calculate my test size, and this is nothing but 500 divided by 5. And here you'll be seeing 100 records. So this will be 100 records. So what will happen is that in the experiment 1, which we also say cross validation equal to 1, in the first experiment, the first 100 records, let's say this is my 100 records, first 100 records, this will basically become my validation data, and this will actually be my training data. Okay, and similarly with respect to experiment 2, what will happen? The next 500 records that you will be seeing, this will basically become your validation data, and remaining all over here will basically become your training data. So again, here you'll be getting an accuracy 1. Similarly, here also you'll be getting an accuracy 2. Now just imagine how many number of experiments I have to do in order to traverse all the 500 records. Obviously, it is very simple. We will go ahead with experimental experiment. How many? See, 5 experiments, because 5 into 100 will cover all the data points, right? So experiment 5, you will be able to see the last 100 records will basically be your validation data point, and this data will basically be your training data points. Okay, perfect. And finally, here you'll be having your accuracy 5. And then I can probably calculate the average of all the accuracies. And as a data scientist, I can say that the max accuracy that I can get is the maximum one out of it, the minimum out of it, and what is the average accuracy, I can basically say with the help of cross-validation dataset. Okay, very, very simple. We have discussed till k-fold cross-validation. Here you can see leave 1 out cross-validation, leave p out cross-validation. Now let's go ahead and discuss about one more technique, which we specifically say it as stratified k-fold cross-validation. Now, before understanding why do we use stratified k-fold cross-validation, let's go to the fourth one. Here, I'm just going to write stratified k-fold cross-validation. See, at the end of the day, cross-validation is used for hyperparameter tuning along with to check how my model performs with respect to the validation data set also. Now, in stratified k-fold cross-validation, first of all, we'll try to understand what is the problem with k-fold. Let's say if we are solving a classification problem, there may be scenario in my test data or validation data, since I'm selecting, part by part, one by one, and trying to cover every data set, there may be high possibility that only one type of categories may come over here. Let's say if it is a binary classification problem, then in my test data, the scenario may be, in my validation data, the scenario may be that all the outputs are ones or zeros, right? We may not get the right combination of ones or zeros as my output. So that may be a problem because my data set is only giving one type of data, and obviously model will not be able to understand, or it will not be able to train itself properly. Stratified k-fold cross-validation makes sure that whatever validation we are doing with respect to different k values, let's say if this is my k value is equal to 5, obviously test size will be 100. Okay, because my 500 divided by 5 will be 100 over here. It's test size, right? Test data. Whenever it is taking the validation part, whenever I say test data, I'm basically mentioning it as validation data. Okay, guys, don't get confused with respect to this, right? So this is nothing but validation data. Now, when this validation data is selected, okay, it will always make sure that the number of outputs will be evenly distributed. Over here, let's say 60-40 ratio, the number of outputs will be distributed, right? If I have 60 ones as my output or 40 zeros as my output. So this is also a balanced data set, right? So in my validation data, always it will make sure that equal amount of zeros and ones will be present. In our training data set, we can have somewhat little bit in a different way, but it will always make sure that in our validation data set, it will probably provide you almost equal proportion. So let's say if this is my CV1, this is my experiment 1, then in the experiment 2, it will try to select the next 100 records, and it will again make sure that my validation data set is proportion with respect to the number of outputs. Now this is an example with respect to binary classification. So again, this will be my validation data set, this will be my train data set. This is the only difference between k-fold and stratified k-fold cross validation. Okay. At the end of the day, it is always making sure that the number of outputs in the validation data set is almost equal so that my model will be able to perform well. Remaining all, whatever things are there in k-fold, the same thing actually happens over here. Now coming to the fifth one, which is again super important. And the fifth one is something related to time series data. So here I'm going to basically write time series cross validation. Now here what we are going to do, I think you have seen a lot of use cases where, let's say, there is something called as product sentiment analysis or product comment sentiment analysis. Like people usually write product reviews, right? I can basically write reviews. Okay, sentiment analysis. Now let's say initially a product is created and later on company adds some more features in that specific product. So initially, let's say when your reviews are bad, later on it can become good, right? So all those reviews that are coming, those are based on time, right? And you can say as we go from January to December, right? Initially in the first quarter, we got bad comments for this product reviews, or we got bad reviews for this product. Later on, when we went to July, September, October, the reviews become better. So in this scenario, what happens in time series? The cross validation will happen based on days or based on some time. Let's say day 1, day 2, day 3, day 4, right? And like this up to day n. Now in this, we divide our data set based on days. Let's say this from day 1 to day 4 is the part of my training data set. Day 4 to day n is part of my validation data set. We cannot randomly pick up days and put it in the training data set or validation data set. We always have to make sure that whenever we are doing the split, it happens based on days, right? The initial number of days, it can be any number of days, right? And this should only be the sequence. We cannot randomly pick up some part from here and put it over here. No, that will not be possible. And where do we apply all the scenarios? Usually in time series application. You'll be seeing, we'll be doing a lot of projects with respect to time series. So in time series application, we will be using this kind of time series cross validation. Okay. And this is the reason, because reviews, something that is some outcome that is related to time will always change. And that is the reason we always try to make this kind of split, right? So this was the basic differences. And yes, as we go ahead, we are going to understand all these types of cross validation, and we're going to implement with the help of Python and sklearn, and we'll see that how we can actually solve it. So yes, this was it from my side. I will see you all in the next video. Thank you.